Okay, and that's supplementary. One specific type of supplementary angles are called a linear pair, and these are probably the ones that get talked about a lot whenever we start getting into proofs, is talking about, well, if you look at the picture, it makes a linear pair, so that means we can do all kinds of stuff with them. And a linear pair are two angles, and this is the big thing, they have to be adjacent. Remember, adjacent means they're touching, so they have to be adjacent and create a line. The angles are always going to add up to be 180 degrees because they do make that line. So if I make you a picture of that, the angles have to be adjacent and create a line. So easiest way is to make a line. We need two angles. The easiest way to create two angles is just to draw a ray coming out from that line. And then there's your angle 1, there's your angle 2, there's your linear pair. They have to be touching. If they're not touching, they're not a linear pair. So looking at the next example, it says angle CGD. So CGD. And we're looking to form a linear pair. So just like we did before, we're going to extend this right here. And all this angle right here, and they have to be adjacent, so we got to start from the ray that makes the side all the way to where the straight line would be, and that is one of our angles that could form a linear pair. So we got angle CGA. That's not the only option up there. So these two right here form a linear pair, but there is one other option that we could list, and that's if we extend this ray from our angle out like this, that's another possibility. If they asked for a separate list of a linear pair for that one, we could say angle CGD is going to be a linear pair with angle DGF. Those could be considered a linear pair as well. Okay. Another one you could see, which angles form a linear pair with angle AGE. So AGE is going to be that one right there. And again, I know it's made up of a lot of little angles in there, but just focus on the one that they're giving you. So we've got angle AGE, and if I extend and look straight out, I've got this one right here. So one option for a linear pair with angle AGE would be angle DGE. Okay, let's check and see if there's another option. So I'm going to check this ray and extend it out there, and there is an option for one. So there's this one, there's our angle we're looking at, and then there's our other angle. So our other option, so it could be angle DGE or it could be angle BGA. Okay. Another type of angle pair relationship that we could have are called vertical angles. Vertical angles are the angles that are opposite each other when two lines cross. So if you have two lines, there's one line, we'll call that line M, and then there's another line, we'll say this one's N. The lines create four angles, but when you're looking at vertical angles, we're looking at the ones opposite of each other. So if I'm looking at, let me number these, 3, 4. If I'm looking at angle 1, I'm looking for an angle that is opposite of it. So if I look opposite from 1, directly across opposite from it is going to be angle 3. So angle 1 is across from or vertical to angle 3. Those two are vertical angles. There's also angle 2 and angle 4. Those two are also vertical angles. So anytime you have two complete lines that are intersecting, there's always going to be two sets of vertical angles. All right, so if we're looking at the example, it says, which angle is vertical to angle 3? So if I'm at angle 3, It's right here. So I'm going to want to focus on the lines or the rays and the extended rays that create the angle. So if I'm looking, that ray right there and that ray right there creates angle 3. But if I extend that ray and I extend the other ray and I look directly across, opposite of it, there's angle 6. So angle 6 is going to be vertical to angle 3. And we can look at another one, looking at angle BGC. BGC. So I'm looking right there. That's the angle they're asking, and they want the one vertical to that. So if I extend each ray, this one's going to go out like that. I've got this one right here. So for angle BGC, I've got angle EGF. And those two angles are vertical from each other. Got one more vocabulary term for you, and it is congruent. Congruent in geometry is when two or more objects are exactly equal in size and shape. So congruent is kind of like geometry's equal sign. Algebra has equals, and whenever you're doing algebra, you compare numbers. When you do geometry, you're comparing shapes. And so you're going to say that the shapes are congruent because you don't have a number to assign to them to say for sure, yeah, they are. You're just told they are. So when it applies to angles, angles are going to have the same exact measure. So they can either tell you, like they could give you an angle, let's say we have angle A, and it's 20 degrees, and then angle B, and it would be 20 degrees. We could say that angle A is going to be congruent to angle B. And the symbol for congruent is kind of like an equals with a curve above it. I call it a mustache. But yeah, it's an equal sign with a mustache above it. And they could also, more commonly, what they'll start doing is they're going to show you two angles, and they're going to put arc marks in them. So you see how that has a little arc there, and that has a little arc there, and it's only one. That means that those two are congruent to each other. So we could go D and we could go F, and we could say that angle D is going to be congruent to angle F. Okay. So if we're looking at example 2, it's asking which angle is congruent to angle 2. And one thing about vertical angles are congruent. So if we're looking for an angle that's congruent to angle 2, they're essentially asking vertical. What angle is vertical to angle 2? So vertical, we're extending the rays again. There's that one extended, there's that one extended. And so those two, what do those create? They create angle 4. So there's your one where they ask for congruent.